June 2026, days before the biggest IPO in history, Elon Musk unveiled a satellite wider than a 747 and called it a data center, not for internet, for AI. The headlines called it science fiction. The blueprints say otherwise. Right now, three of the most powerful companies in technology, SpaceX, Google, and NVIDIA, are racing to move artificial intelligence off the planet and into orbit. The pitch: unlimited solar power in the cold of deep space for free. By the end of this video, you'll know who actually wins this race through 2027 and the two numbers that decide whether the data center ever truly leaves Earth. Why would anyone put a data center in orbit? Start with the wall the AI boom just hit on the ground. A single gigawatt scale cluster now needs its own power plant, millions of gallons of cooling water, and years of permitting. Grids are saturated. Communities are pushing back. Space offers a way around all of it. In the right orbit, the sun never sets, so the panels never stop. And the universe itself is the ultimate heat sink, sitting near absolute zero. Free power, free cold, no zoning board. That's the theory. But three companies are chasing it three completely different ways. One giant spacecraft, one swarm of small ones, and one that just sells the chips to everybody. Each bet reveals what they think the real constraint is. Start with the boldest. SpaceX calls it AI1, and Musk says it's actually simpler than a Starlink satellite. The numbers are not simple. One craft carries a compute payload of 150 kilowatts at peak, 120 on average, fed by a matching 150 kilowatt solar array. It stands 20 meters tall with a wingspan of 70 meters, wider than a 747, and critically, the chip payload is interchangeable. SpaceX isn't betting on one chip maker. It's building a rack in orbit you can slot any accelerator into. The plan: launch them on Starship, 60 at a time, and eventually fly a constellation Musk has sized at up to 1 million satellites. In February, SpaceX absorbed Musk's AI company, XAI, into a single entity valued around $1.75 trillion. It's planning a Texas chip fab, branded Terafab, that filings suggest could run from $55 billion to as much as $119 billion. Own the rocket, the fab, the model, the orbit. Musk's claim is blunt. Within 2 to 3 years, the cheapest way to make AI compute will be in space. The strategy is to make that true by controlling every layer and rent the rest to everyone else. Google is chasing the same prize with the opposite design. Project Suncatcher isn't one enormous spacecraft. It's a swarm. The plan flies 81 satellites in tight formation, about 1 kilometer apart, and treats them as one distributed computer. Each carries Google's own silicon, Trillium, the 6th generation tensor processing unit, the same chips that train Gemini on the ground. What stitches them together is light. The satellites talk over free space optical links, beaming data at tens of terabits per second, with no fiber and no air in the way. If you've seen this channel's episode on the optical fabric, this is that idea in its purest form. The network is the computer, and the wires are laser beams. Google picked a sun-synchronous dawn-dusk orbit, riding the line between day and night so the panels almost never see darkness. It has already radiation tested the TPUs for a 5-year life, and it's working with Planet to fly 2 prototypes by early 2027. Google's bet is the inverse of Musk's. Not one giant, hard-to-replace machine, but many small, cheap, redundant nodes knitted together by optics. If one fails, the swarm routes around it. The constraint Google is designing for isn't power, it's networking. While SpaceX and Google design their own chips, a third path is already in orbit, and it belongs to the arms dealer. NVIDIA doesn't need to win the satellite war. It just needs every satellite to run its silicon. Enter Starcloud, a startup that hit a $1.1 billion valuation faster than any company in Y Combinator's history. In November 2025, it flew a small satellite carrying an NVIDIA H100 and became the first to train a large language model in space. Not a simulation, real weights updated in orbit. Its next satellite carries a Blackwell B200 with roughly 100 times the power of the first. And NVIDIA made the path official. At its 2026 GTC conference, it unveiled a Vera Rubin space module, a version of its next-generation Rubin GPU built for orbit, claiming up to 25 times the compute for space-based inference. It's the same playbook NVIDIA ran on the ground. It didn't build the cloud, it sold the cloud its engines. Whether the winner is SpaceX's Giant or Google's Swarm, NVIDIA sells into both. The merchant of compute doesn't care whose flag is on the satellite, as long as the brains inside are green. Now the part the pitch decks skip. Space gives you free cold, but it won't let you use it. On Earth, you pull heat out of a chip with water and moving air. In a vacuum, there's neither. Heat can leave only one way, radiation, and radiation is brutally slow. Starcloud's own white paper admits a radiator held near room temperature sheds only about 633 watts per square meter, more than 1,000 times slower than water cooling the same chip on the ground. That's why AI1 needs up to 110 square meters of deployable radiators just to survive. And why on these designs, the cooling hardware can outweigh the computer it cools by nearly 10 to 1. Then there's the money. Starcloud's models only reach ground competitive power, about 5 cents a kilowatt hour, if launch costs fall to roughly $500 a kilogram. Today, the going rate is closer to $1,500. Miss the target, and orbital power triples to 15 cents, pricier than the desert you were trying to escape. Even space advocates, like Voyager's chief executive, call cooling one of the hardest unsolved problems in the field. So who wins the race to put AI in orbit? On the scoreboard, the honest answer through 2027 is nobody yet. These are prototypes, not products. But the real verdict, the one this channel exists for, is who gets paid no matter which satellite wins. Winner one, whoever flies Starship cheaply. Every orbital business case lives or dies on that $500 a kilogram number, and one company controls it. SpaceX's prize may not be compute at all. It's becoming the railroad every competitor has to ship on. Winner two, the thermal supply chain. When heat is the binding constraint, the boring hardware wins. Deployable radiators, two-phase pumped loops, the firms that turn kilowatts into radiated watts. Performance per watt just became performance per watt per Kelvin. Winner three, the most efficient silicon, whoever makes it. That interchangeable payload in AI1 isn't a detail. It's an admission that the chip is a commodity slot, and the winner is whichever accelerator dumps the least heat per token. The data center really is leaving Earth, but it won't be the boldest satellite that decides it. It'll be a launch number and a cooling number. Watch both. That's the orbital compute race. The numbers, not the press releases. The actual semiconductor industry view is this. The AI story is, in the end, an energy and supply chain story, whether on the ground or 400 miles above it. If you want the foundation for all of it, what a gigawatt of AI compute actually costs and who pays, watch the Compute Economics breakdown on your screen now. And subscribe so the next deep dive finds you. The AI race is decided in the supply chain. Here we keep score.